G'day, I'm Mark Hoth and welcome to Swift Almanac, where we teach you the basics of Swift in 10 minutes or less. Today's lesson is automatic reference counting, or ARC, and this includes retain cycles. In memory management, data types which use values are easy to manage, as each time they are assigned, a complete copy is made, and so at the end of a closure or function, it is easy to automatically deallocate the memory, which is what Swift does. However, with classes and other data types which are passed by reference, Swift keeps account of how many of these references are in use and only deallocates the memory when there are none left. On occasions, this can lead to memory leaks. So let's have a look at automatic reference counting in 10 minutes or less. Automatic reference counting. So how does it work? Well, let's say we have a very simple class. And so this class has got a constant name, it's got an initializer which sets the name to the value of name, and it prints out the message name is being initialized, and it's got a deinitializer which simply prints out the name is being deinitialized. So we'll get messages when we initialize the class and when we deinitialize the class. So to create a reference, we just go variable reference 1 and set that to optional person, and that is going to create, well, it's going to set it to nil, and then we'll go var reference 2, an optional person, var reference 3, optional person, and then if we go reference 1 equals person and then use the initializer, then we've assigned the class person to reference 1 and our ARC count is now 1. And then what we can do, in fact that's a strong reference to reference 1, and then what we can do is we can go reference 2 equals reference 1 and reference 3 equals reference 1, and we've created 3 strong references to the class of person. So our ARC count would be 3, and then we can simply wipe them by saying reference 3 equals nil. And so we've got rid of 2 of the references, so our ARC count is now 1, and then finally if we get rid of the final reference, which would be reference 2, and we go nil, once that runs, Swift will deinitialize it, and you'll see down here at the bottom that John Appleseed has been deinitialized. So when we were back up here, John Appleseed had been initialized, and it had been initialized once, and the other 2 were just creating references to the same class. And then when we deinitialize all of the, once we deallocate all of these, then we get this deinitialization happening for the bottom. So that's how strong reference cycle works. Now let's look at a retain cycle. Okay, let's look at retain cycles. So with our person class, we've added that the person may be in an apartment, and we've created another class, a class of apartment, and that's got the name of the apartment or unit, and there's also this tenant variable. The apartment may or may not have a tenant involved. So in this case, person points to or can point to apartment, and apartment can point to person. So let's allocate some variables. Okay, now we can link the two together, so we can force this John.apartment to equal unit, and unit, same story, we can force the tenant to be John. We can do that because we know that they're already allocated in the line above. And then simply, if we go John equals nil and unit equals nil, so these deinitializers are being called because we've added in this weak reference. In addition to weak references, there are also unowned references. And unowned references are used when an object is dependent on another object for its existence. So in this case, we have a customer who may or may not have a credit card, but the credit card definitely has to have a customer. And so we use this unowned keyword to let us know that this is a one-to-many relationship. So here we can create the variable customer and then customer and customer.card equals, oh, what am I doing? Credit card So here we have a strong reference from the customer to the credit card. These should be underscores. Underscores in Swift numerics are not counted, so that's actually a 16-digit number. So here we have a strong reference from customer to the credit card and an unowned reference from the credit card back to the customer. So when we go, the customer is nil, that is going to deinitialize both the card and the customer automatically. And we made it. Well, that's it for ARC and retain cycles. Hopefully you've got an understanding of how Swift memory management works and how to avoid memory leaks. If you have any questions about the tutorial, then please leave a comment below or hit me up on Twitter @SwiftAlmanac. Please subscribe to the channel, it's free, and check out our website at www.swiftalmanac.com. Thanks for watching, and we'll see you next time. Cheers.